Welcome to the Interop. Today my guest is Karel, aka Kaiser Karel. He's the CEO of Union. They're building zero-knowledge infrastructure for interoperability that will enable permissionless and trust-minimized message passing between the Interchain and Ethereum. This is a fascinating conversation, and we'll be discussing Karel's background as CEO of Composable. We'll talk about the Union stack and the architecture of the protocol. We'll discuss Comet BLS, it's their BLS implementation of Tendermint. We'll discuss Galois, it's the ZK prover that they've built, as well as Voyager, their stateless relayer. We'll talk about fixing the fungibility problem and also the use cases for Union, and one that I'm particularly interested in, which is renting Ethereum security for Cosmos chains. We'll also talk about their plan to bridge Bitcoin over IBC, which is incredible, and so much more. I'm also dying to find out why he thinks Cosmos is making a huge comeback. Before we get started, make sure to hit the like button, hit the notification bell, and subscribe to get notified when new episodes drop every week. And remember that none of what we discuss here on the Interop is investment advice. And if you enjoy this content, please consider staking with us. We're validating on Evmos, Quicksilver, Osmosis, Juno, and Nolus. Just look for the Interop in the active set. My guest, Karel, is coming up next, right here on the Interop. Karel, thanks for joining me on the podcast.
Yeah, great to be here.
We've been talking about interoperability on the show for as long as there's been the Interop, and I think we've covered like pretty much every interoperability protocol out there, maybe with the exception of layer 0, for some reason. But maybe because it's a little bit not so trust minimized as I like it. But basically that there's like a wide array of different interoperability solutions, and I think you guys are really trying to position yourselves as a highly trust minimized and highly permissionless interoperability solution for crypto. But yeah, before we dive into Union and how it works and the different parts of the architecture, I would love to hear a little bit about your background. So previously you were CTO at Composable. You left the company, I believe, last year. Tell us a bit about like what that experience taught you as in terms of like the complex problem of bridging blockchains, and how it better equipped you to be the CEO of Union.
Exactly. So I originally joined Composable as a senior engineer and actually climbed my way up to CTO. I led different teams there, including the originally interoperability team, the bridging team, where we hadn't actually settled at the time on IBC. So we realized the need for a trust minimized solution based on light clients. And right as we got started with this was actually before like the first ZK rollups launched. So ZK light clients and such were also really far away and actually quite theoretical in their performance. So we set it around a light client based model, and then started implementing the actual protocol and thinking about like, besides being able to send state proofs across chains, what else do you need to build on top of this to avoid eclipse attacks and other types of attacks? And there we kind of realized that we were starting to re-implement IBC. Because if you want to do it with the least amount of on-chain operations, with taking all these different attack vectors into account, you're going to either do IBC or something that's less efficient than that. That's actually the moment when Composable decided to bring IBC to Polkadot, to different ecosystems. Our initial experience was around like that whole tech stack. So I worked a lot with Jack Zampolin and the ICF to basically dig through what we need to do to port it to a completely new code base, right? Like a Rust substrate-based code base, as well as a different consensus model using Grandpa finality and later Beefy instead of Tendermint. And that kind of builds a lot about what we're doing with Union, because there as well you encounter the struggle of basically only being able to use like the core IBC protocols and the specifications, and needing to build an entire system from scratch to be able to handle Ethereum and other rollups. So yeah, we focused a lot on building out these kind of core infrastructure solutions, relaying on-chain contracts, and basically got to know like the real ecosystem around IBC, which is a very varied ecosystem as well, with parties like Informal, Strangelove, the ICF, all working different modes. So for us, that was really getting used to it, because at the time in Polkadot, you kind of had Parity, which is a god emperor of tech that guides the entire parachain group
Yeah.
forward. And obviously, Cosmos is very, very different in the way that parties collaborate with each other. I think fundamentally a stronger way. Like having this god emperor of tech makes it seem initially like you're going to move quicker. It's probably easier to raise a lot of VC funding, which Polkadot obviously did. As you now saw with Parity letting go of 300 developers, it's actually not a really strong way to scale an ecosystem. And actually having individual builders try to compete with each other and race to the finish to a first implementation leads to a much more diverse and stronger ecosystem. So going into Union, we basically took those technical lessons with us, but also the kind of political lessons, as well as the agile lessons of seeing it as a really competitive space and focusing a lot on this idea of what can we bring to the space that is immediately going to be useful to protocols? What do people actually want to use?
Yeah, that's always been one of the things that attracted me to Cosmos is this market approach to building tech. A lot of times I've described it as the cathedral and the bazaar when comparing it to Polkadot. And I mean, I'm not the only one who's used this analogy, but it sounds like you're a pretty big Cosmos bull. What are your thoughts on the Cosmos ecosystem right now and like where it's heading?
I think we kind of see the payoff of years of building now. Obviously, when token prices go up, community members are happy. When teams are raising, they are happy. Throughout the bear market, everyone gets extremely unhappy. You might even see influencers start complaining about builders. Are the devs dumping? What's actually happening here? But I think Cosmos, we're seeing a really great payoff of teams that actually continue to build. That's all coming to fruition right now. Look at Celestia, look at DYDX. Think Injective's doing great. I think overall, like actually teams that were kind of outside of the inner circle that have been building relentlessly are now really going to production or are in production and really successful with what they're doing. And to me, that's going to be like a massive combination of factors that will basically, I think, allow the entirety of Cosmos to outcompete certain roll-up ecosystems as well. I think we saw a lot of hype with new roll-ups, and once again, like copy clones of the same Ethereum contracts going everywhere. But I think in Cosmos, we're going to see some actually really interesting products that end users want to use, right? Like when you control your block times, when you control your actual consensus, that's when you can build really nice, cool stuff.
Yeah, we'll talk a little bit about that later on, but I think one of the major shifts that's coming to Cosmos, or at least we can see is the utilization of ETH security in Cosmos, and that I think will play a big role in making the ecosystem a lot better and just securing the ecosystem in a way that hasn't been possible up till now. So let's shift to Union. Um, so what is the Union product, and what's the main problem that you're trying to solve with this protocol?
Yeah, so I guess if you were to like draw a Venn diagram, then Union wants to be to app chains, rollups, separate state machines, what Celestia is to them for the DA, but for interoperability. Relatively similar to Highplane in the sense that we want to be like plug and play and permissionless, but it's all built around IBC. So in our case, we don't rely on teams deploying us to run their own multi-sig validator set or rely on the wormhole guardian set. Instead, we rely on light client proofs to actually facilitate this bridging. The big problem I see with IBC right now is the fragmentation, as well as the need to do governance proposals to open these channels. So we haven't yet really created a product that allows us to spawn 100,000 chains and actually get all of them connected. While in like regular Web 2, we can obviously easily spawn 100,000 servers and all connect to the internet and start communicating that way. And what I really want to see and why I went into interoperability is this world where everything's on chain, everything is a blockchain, it's all communicating with each other, and it's all verifiable. So with Union, we're really setting out to build that. Our initial product is very much focused on adding something new to the ecosystem. Because I think in the kind of Tendermint Cosmos SDK space, we figured out how to open IBC channels between these chains themselves, use osmosis as a router hub. But I think what like provides the most interesting new avenue for TVL as well as new products is the ability to do IBC back and forth to Ethereum. There you encounter a few issues. Obviously, verification on Ethereum ultra expensive. So if you go with the naive implementations of doing it without any ZK tech, you're going to spend I don't know, somewhere between 5 to 10 million gas, depending on the amount of validators you have for last night's updates. Perhaps for like a really big chain with massive TVL willing to throw 30 million USD against this a year, you could actually do it and operate the IBC channel that way. But you want something more elegant. And so that's what we set out to build with Union, and what we have live right now in testnet, an IBC channel that uses our prover, Galois, to generate ZK proofs for our chain and submit those on Ethereum, as well as on the way back, doing asset transfers and playing ping pong.
So we've talked a lot about this on the podcast, and like we just had Hyperlane on last week, so it's interesting that you
Mm-hmm.
mentioned them. But yeah, let's just remind everyone and get a refresher on like why verifying state between Ethereum and Tendermint and Ethereum and other maybe like Avalanche or other consensus mechanisms. Why is that hard, and why does it require another solution than just being able to verify the state between the chains as Tendermint chains do?
Yeah, so for Tendermint chains, they have been partially like really well designed for interoperability because you've got single slot finality. So you kind of know if you see a block, it's going to be finalized. You can generate a proof for it and submit that to another chain. What's a real kind of issue with it right now is the way that validators vote and sign blocks, like the finalization process. It uses signature schemes for which there's no pre-compiles available on Ethereum. They vote on technically different payloads, which means that you cannot aggregate these signatures cheaply in a ZK circuit. And so I would say that like the core ABCI is kind of like 2019 tech itself. Whereas in cryptography and consensus design, we've got a lot of better designs right now which you can apply to it, which also make Tendermint to Tendermint IBC a lot more efficient and lower the state growth and make verification cheaper. Going from Ethereum to other chains, the real issues that you run in is obviously that Ethereum is just a massive validator set. So actually keeping track of that part of the consensus is extremely expensive. Luckily, Ethereum has this concept of signing committees. So they basically aggregate in stages to perform this finalization process, which still a lot you need to keep track of. But in this case, they did apply some really good thinking where they use BLS signatures to sign the payloads, which makes Ethereum verification very feasible at the moment and also quite ZK friendly. So you kind of want to, when you do IBC to Ethereum, the real problem is the live client updates that you put on Ethereum itself. And kind of see with, for example, Succinct Labs solutions. They've got telepathy, great product, that they mainly focus on L1 Ethereum to other chains because that state generation works, still takes quite a long time. If you look at their ZK Tendermint, I think they do updates about every 100 minutes. So you already see kind of like if you just take vanilla Tendermint and build your product around that, it's going to work okay for a product like Blockstream, where your latency requirements are very different. But if you want to do asset transfers and something that's much closer to the hot path of user interactions, then waiting another like 100 minutes for a bridge settlement to be finalized. At least me as a bridge user wouldn't really want to use that. I don't want to set a timer and go back to my dashboard 100 minutes later to see the transaction being bridged. So with Union, what we did was we had a look at Tendermint to optimize it for verification on Ethereum, apply like the latest cryptography and consensus engineering. That's Comet BLS, and that's actually like turned out to be massively successful in this approach. So proving times are at the moment for V2 sub 10 seconds, can run on an M2 MacBook, can scale to 128 validators. We benchmarked it, but because of BLS signatures, you can scale to many, many more validators. And so basically, we managed to create a system where A, you have this state verification, full IBC stack, all compressed in a zero knowledge proof. B, you can actually produce these proofs on consumer hardware. Once we started building Union, we didn't want to create a system where we would need to burn 400K US dollars a month on cloud infrastructure, where we had these like massive build farms to generate these ZK proofs. That's kind of what you run into when you're in a ZK rollup, and why like sequencer decentralization is so hard there. And we didn't want that for a bridging system because we really wanted Union to be a system that could be run by anyone, because then it's a truly decentralized system and you're allowed to make it permissionless. If we as a centralized party are the only ones that could feasibly produce proofs, we would become a financial institution. and we would have to stop serving American users. We would have to abide by all of the new laws that they are creating. So it's just much better to create a system where we ourselves don't have an off switch and don't have a censorship switch at all. And where even if Union Labs were to disappear, Larry or Gadikian might just spin up a server and start continuing proving to keep the IPC channel operating. So we managed to kind of achieve that in the first 6 months that we're building. And so that's when we came out of stealth, willing to share this with a wider audience.
So when you say that proofs can be generated on consumer hardware, what does that unlock, like practically speaking, for a user or in terms of like censorship resistance or liveness safety?
Yeah, so it's like considered an edge case issue, right? That the entity that built the protocol disappears. We're supposed to design protocols in such a way that it doesn't matter. But we have seen this happen before with bridges where the dev team might be out partying while a hack happens, or the CEO might be involved with some shady operations and be arrested in Shanghai. Bridge goes fully offline, 500 million in value is locked. Protocols that hold their wrapped assets are currently completely depacked, and you've got an ecosystem-wide crash. So you totally want to avoid this situation. With the way we've built this and built upon IBC, even if after 10 years the Union team calls it a day, or we were all to die in a plane crash, all these IBC channels that are operational and relaying assets plus controlling assets in different faults can be operated by a new relayer. So as an end user, the real risk that you have when using our protocol is that you might need to read the docs and run a relayer. For an end user, it's less interesting, right? Like your regular crypto user might not do this. But as a protocol integrating, this is really valuable. So in the end, when your protocol on another chain accepting assets from a bridge protocol, you have to realize the risk of holding these wrapped assets. The original protocol gets hacked on Ethereum, you're going to deal with unpacked assets. Your TVL goes from 100 million to zero, your revenue suddenly drops, your existing treasury might drop to zero. So you want to avoid all these risks. And one of those risks is, can I keep operating this myself without doing a massive migration? And in our case, you can.
So I'd like to maybe talk about the architecture a little bit, and start by just pointing out that Union is in fact it is a chain, right? So different from like succinct or electron, where there is no intermediary chain that either generates or verifies proofs between the two chains, the destination chain and the receiving chain. Um, there is a chain for Union. What is the role of that chain? What does it do, and like where does it sit in the transaction flow?
Yeah, we set out to do a similar model as we did with Composable, where we have a bridging hub chain to route traffic. That is basically because, as I said, like even with the ZK Live clients, we're still paying gas for IBC channel updates. So if you want to connect 1,000 Cosmos chains to Ethereum, you ideally don't want to do 1,000 individual channels, because for 99%, that's still going to be too expensive to keep operational. And we already have a lot of complaints in kind of the ICS space, the relayer space, about incentivization, funding, etc. So massively increasing that is not a good approach if you want to go to market in the next 2 years. Another reason we chose that is because we could apply those optimizations that we did with Comet BLS. What it does add is an almost majority assumption on the Union chain itself. So the model that we designed, I think you read about this in the white paper, was that basically as long as you can still create a ZK proof for the chains that you're connected to, you can basically do ZK fraud proofs. So your hot path goes through the virtual fast Union channel that uses Comet BLS, with the ability to show that fraud has occurred in the case that the entire Union validator set itself has become compromised and the chain is in a foobar state, and switch to the slower channel. In this case, the only bridging risk that you have is the IBC rate limit times the amount of seconds it takes to generate the ZK proof for the counterparty chains. And so this usually results in about IBC rate limit times 5 minutes, which is a very acceptable bridging risk. So now you've reduced it from 300 million to 15K or whatever you find acceptable with the rate limits.
Okay, so Union, the chain, it's like the chain serves to do proof verification essentially for tokens moving or messages moving between chains. If that chain were to disappear, someone else could spin up infrastructure to do this. This is where that fallback mechanism
Yeah,
comes
exactly.
into play.
So basically, we make use of stuff like proxy light clients, multi-hop routing. So two chains connecting union that want to interact with Ethereum or later rollups on other chains. It is like a channel directly to that chain itself with a secure fallback mechanism in case the intermediate chain gets into a foobar state. For us, that's also why we early on started exploring shared security. For us, it became really interesting to see if Union could be partially secured by mesh, partially by eigenlayer, because obviously then you're secured by the two major ecosystems that you're bridging in between, which makes a lot of sense overall if your underlying trust assumption is on these two ecosystems, being honest.
Yeah.
We've definitely chosen a solution that's somewhere in between trustless and like a NPC validator set, right? Like we do add a chain in between. So we refer to it as trust minimized. But for us, at least, that's one that basically gets you to a really good product in time. It also opens up new products that require this hybrid model. So if you look at rollups, for example, that have maybe a complicated fork choice rule or integrations necessary with a DST network, you're probably not going to be able to do all of that inside the light client chain contract itself. And so you probably want like an L1 to actually be properly able to integrate with those infra layers.
Cool. So when you're talking about the chain itself, so we mentioned this a little bit, but you talked about Comet BLS, which is another implementation of Tendermint that uses BLS signatures instead of ECDSA, right? Can you describe like what that like? Why did you do this? And I guess my other question when I was reading the paper is, would other Cosmos chains benefit from switching to Comet BLS? Would they? Is there like some unintended sort of like benefits to using that over regular Tendermint, or is this something that basically is only useful in the case of Union or some edge cases?
No, it's I won't say drop-in replacement because the Tendermint stack is very monolithic at the moment, but there's a lot of effort being done by the ICF and Strangelove to make this a lot more modular. So we're kind of playing into this, and probably will be kind of providing Comet BLS as a plugin once that rewrite has occurred. It's more efficient for regular IBC between Tendermint chains as well. So you already benefit immediately from using this. You get less state growth, less block space allocated to lifetime verification. It works really well for browser light clients too. So overall, like you get a much better consensus that's like truly geared for interoperability. And we have some additional changes to this as well. So the way we lay out like the storage trees themselves is different. The hashing algorithms we use are different, all geared towards making verification a lot more efficient and cheaper to do. Um, Ideally, like we'd actually love if all Cosmos chains were to switch to Comet BLS, or if you could upstream Comet BLS into Tendermint. The problem is upgrading is a consensus breaking change. So if Osmosis were to do this, they would need to coordinate this with validators. There would need to be a way to keep existing IBC channels live. So there would need to be a specification for how to upgrade IBC channels to a completely different consensus across chains. Alternatively, you can close them all, do the upgrades, reopen them, but that would mean that you have different denoms, so no other headache to deal with. So a lot of the reasons why these changes really aren't present in Tendermint as well is because once you're in production, it's almost impossible to get this in place. But for brand new chains, do talk with us. It's a super interesting way, especially if you want to have that direct channel to Ethereum yourself.
Mm. Can you explain then why BLS signatures are important in this context, or why they're superior or better suited for interoperability than ECDSA, like specifically when talking with Ethereum?
Yeah, they basically just allow for aggregating these signatures themselves. So if you and I both have a BLS key and we both sign exactly the same data, you can kind of visualize that we just add both our signatures to each other. So if your signature is number 3 minus the number 4, that becomes 7. And if we do the same operation with our public keys, if we add them together, then that new public key that we derive matches the addition of the signatures. And this kind of unlocks this idea that you can scale to 100,000, 200,000, 300,000 validators because you simply add all of their public keys together and all of their signatures. And then it's the same as if you were verifying a single validator network. So with Comet BLS, that's why like in our benchmarks, we scale so well. Basically, they reduce to a single validator network if you want to do the bare minimum verification after aggregation. On top of that, here there's more ZK friendly. So doing these aggregation operations in a ZK circuit is relatively efficient. There's pre-compiles available on Ethereum to perform these operations as well. So I think like a regular like BLS verify on Ethereum is going to outshine like regular signature verification after about 25 signatures on the top of my head, which means that for almost all Cosmos chains out there, it's a more efficient implementation to do so.
Okay, so practically speaking, if we just bring this back down to the chain, right? So the validators on the chain are performing are checking these ZK proofs, and so you want to have an honest majority that is signing this proof, attesting that the proof is valid. And so by having a way to aggregate those signatures into one signal signature, it's much easier and much quicker to verify that final signature rather than having to do this sort of like in series or in parallel of verifying like maybe 25 or so, however many end signatures all like in a batch.
Approximately, yeah. So if you were to like write a ZK circuit, the like baseline, like if you start out just tinkering around with doing consensus verification, is you're just going to verify 100 signatures in a list. And if you were to do that for regular Tendermint, what you'd realize is that your map to curve operation is going to be different for every single validator. So you can't actually do that once in the circuit. You need to do that 100 times. Then you're going to realize that the signature algorithm that you're using is actually not ZK friendly at all. So it has a really large baseline cost. So for every validator you add, you're going to be paying that baseline cost, which is going to dominate what you're doing. Same for basically destructuring the storage proofs that you're using, because when you do block header verification, you do use storage proof tag there as well to verify that the current set of validators at this height is like the signatures you've got access to. And with BLS, you avoid a lot of these issues. And so by using that, you basically only do one aggregation, verification, and then you get a really fast proof that you can generate. If you then want to fall back to native verification as well, you basically benefit from exactly the same benefits, right? It's like native verification, just regular Golang code, doing the live client stuff, is the same as the ZK circuit in their business logic.
What's a storage proof and how is it used by Union? I've
So
heard this term before, but I'm not like exactly sure what it is.
I mean, the term is like used very widely in the space, storage proof, state proof, but basically the block header contains Merkle trees that point to different data. So one of the trees it will contain is the validator root, which contains the kind of current set of validators and how much voting powers happen to them. This is just a simple hash, but by providing a path of hashes to the actual validator, you can show that a validator is part of the current set. So when you're doing this ZK proof, you basically provide for 100 validators their inclusion proofs, and that way in the circuit you can show at block number 10, these are the 100 validators that are going to be signing. Now, if this operation is quite expensive, doing these inclusion proofs, then you're going to be spending a lot of proving time on just showing that at this block, these are the validators. On top of that, these storage proofs, inclusion proofs are used in ICQ. So when you do these interesting queries, they're used in the sending of packets. So they're baseline for I620. So you see them everywhere where you're in Interop. And that's why it's so important to try to really optimize this part of your pipeline.
Cool. Okay. And so one of the other things that I learned here is that through reading your docs is that BLS enables much larger validator sets, specifically in the context of Tendermint, which usually is optimized for like a small-ish number of validators. That's like 150 to 200 validators. After that, it starts being inefficient. How does BLS enable having lots more validators, and what would be the practical benefits?
Yeah, so basically that same aggregation mechanism that you can use for aggregating pub keys and signatures, you can use that to shard a validator. So the network might think that there are only 128 validators validating this chain, but each validator can be 1, 10, 100, 1,000 validators that are each aggregating their BLS signatures before submitting the final vote to the chain itself. And so this is really interesting for parties like Obol or other decentralized validator networks, because they don't necessarily need to change the core consensus to still implement this sharding. Now, if you combine that with kind of what you're looking for with the eigenlayer, then you can end up with these hybrid type models where perhaps you've got validator nodes that don't verify all transactions, but only prevent double signing from happening. So let's say 10 validators cooperate, 5 of them verify the full block, 5 of them only verify the double signing. Now you've got 5 that run a much more lightweight process. They might be running like as an eigenlayer module itself, an AVS module, because you don't want to have too high infrastructure requirements for running those. And so then you can start actually going above like 150 validators to scaling it to a much larger set, where perhaps in case of validators dropping out or becoming unresponsive in these smaller pools, other nodes picking up their work as well, without the main chain being aware that this is actually going on. You can only do this with BLS signatures unless you want to like adjust the core consensus of a chain. So in the case of Union, for example, if a third-party protocol would want to come along and implement this, then they wouldn't necessarily need to like talk with us at all or make any changes or do a governance proposal. They could implement this mechanism in full themselves. I think it's super interesting as a solution to kind of what ICS is struggling with, where you don't really want to like have every single validator that's running an Atom validator spin up an entirely new server for a new chain they're validating. Something that Polkadot did really well, where like new parachains can be permissionlessly added, and you don't actually need to interact with the Polkadot validator set to have your blocks be verified as well. And ICS really needs like a type of technology that can bring this as well, basically just allow exponential scalability instead of linear.
Okay, no, that's interesting. So, I mean, you could also do this with like, I mean, this is sort of like a threshold signature scheme, or it's similar, right? Because I think Obol, I don't know if Obol, did they use BLS or they use like some
Yeah,
other ECSA
I think
threshold signatures?
I think they use threshold signatures. I would say like it's similar. The problem with current threshold signature algorithms, which works well if they're only sharding into like 50 validators, but they don't scale that well if you go over this set. Because I think for the current state of the art algorithms, for every party that you add to the set for the signing itself, it's like O squared complexity. But don't take my word for it. I would need to read up back on this for the current state of the art. But so it doesn't scale as nicely. While with BLS signatures, it's once again that simple addition that you're doing, which is why Ethereum chose for BLS instead of thresholds.
Okay, very cool. Wow, I'm learning a lot about BLS here. This is great. Uh, part of the architecture, there's two other parts of the architecture that's mentioned in the docs. One is Galois, which gave me some really bad memories of my dorm when I was a student in the north of France and living in the Galois residence, which was a terrible, terrible place to live. Uh, but but also a great mathematician, and also Voyager, which is the relayer architecture. So yeah, which one's it best to start with?
I think I already touched upon Galois, so I can kind of wrap that up. So that's the magic sauce, right? It's like a Comet BLS is very well designed, and the testnet as well, like operational, well, about to pass, I think 900K blocks, maybe a million even. But like the real magic is, can you actually translate that into ZK proofs? Okay, can you generate them quickly? And with Galois, we can do that. Right now, it's on the CPU backend, V1, Comet BLS V1. We run that on, I think right now, a 32 core machine. So relatively pricey, but still very feasible to buy. I think Threadripper is about 3K at the moment. With V2, it's actually runnable on M2s. We have an experimental GPU backend as well, which increases the performance even further. So that's really where kind of the low level coding stuff comes into. In the end, for people that want to run it, it's just a gRPC server. So deploy it on the server, make sure it's on the correct hardware. You get an endpoint that can generate the ZK proofs for you that you use in your IBC relayer. And Voyager, Galois was like very nice to build, a little bit mathematical, nice optimizations, works very nice in its sandbox flawlessly. Voyager is where we deal with the nitty gritty stuff of interoperability and relaying. When you IBC relay between tenement-based chains, you've got single slot finality, which means when you submit a transaction, you know you've handled the packets. When you interact with Ethereum, there's sometimes short-running forks, there's gas price increases, there's a lot of stuff that can go wrong. While even though you submitted the IBC packets and a node says that they accepted it, you might even see it in a block. 2 blocks later, it might be disappeared if it was on a fork, and now you need to resubmit it. So that's where we basically integrate with the Ethereum RPCs, where we deal with all of the nitty-gritty of retries, forks, etc. It's a competitor to Hermes and the Go Relayer, written in Rust. We chose not to continue working with the Hermes code base itself because at the time they were already planning or even undergoing a rewrite. So that has been in a lot of flux at the time itself. And the entire model of Hermes is very different. Hermes is very stateful. If you're a programmer that does a lot of RPC mixing, IO coding, kind of realize how difficult it is to figure out a really stateful application. While Voyager is stateless and built on a message queue. So that's much more similar for the technical people out there as if it's an internal Kafka queue, where we have like a stream of messages which are processed by individual workers, handled, retried, stored, etc. For us, it's been really beneficial so far because it was much easier to debug than the Go Relayer or Hermes, which when we start developing most Ethereum RPC implementations barely supported the beacon chain and broken RPC endpoints. We encountered so many internal bugs working on that. So having a really good relayer to catch all of these issues was crucial.
So the relayer, I think I read somewhere, as you said in your talk, that Voyager was it can connect to any counterparty chain. So I guess like from the Cosmos, this is where always where like it gets funny for me. So like from the Cosmos perspective, I understand then like where the relayer sits with regards to the chain. When messages are sent to Ethereum, what's happening there? Like, who's running the relayer infrastructure there to receive those messages and to send them to the Ethereum chain? And also from the perspective of Union, are you deploying sort of general purpose contracts that are meant to send and receive messages, or are applications integrating Union directly within their sort of like stack to perform this function?
Yeah, so obviously, like the Union team will be running an IBC relayer, like we're doing in testnet right now. We're doing that for our next demo. That's part of maintaining the product. We're not really optimizing the infra that we're running it on. So the way we're designing this is that a large portion of the transaction fees go to the relayer that actually submits the transfers to other chains, which means that you create a market dynamic, right? Because every single relayer, like an MEV searcher, then going to sit on packets that still need to be sent out, do a computation. How much can I earn from this? At some point, they're going to bite the bullet and actually transfer this batch of messages to take that fee. If you've only got one party doing it, they'll basically be quite unoptimized and wait a relatively long period of time to capture this fee. While if you have multiple parties looking at this, obviously they're going to start competing with each other because the one that does it first gets the fee. And this is kind of core of our philosophy, where we want to create a system where there's a really healthy market dynamic, because a healthy market dynamic self-optimizes. For me as a developer as well, if I see a protocol and I think I can make some money here by developing stuff, that's the biggest draw for me to actually develop on a protocol. It's not a third-party grant. It's not the fact that they've got an SDK in 10 different languages. It's the idea that there's an opportunity to enter this market and outcompete all the players. So parts like CISIC or the Neil Foundation can integrate their proving markets. So more professional ZK proof generators can basically make use of this. Technically, the way we designed is that the proving and the relaying are separate components. Although if you want to capture the maximum amount of revenue you could earn here, you want to run both. Ideally, like in the next couple of years, we'd love to see parties like Skip Protocol evolve into parties that both capture MEV, protect from MEV, deal with proof generation, packet relaying, etc. Because all of that is the same problem, right? It's ordering transactions to generate revenue, and cross-domain MEV is already an issue for parts like Sunway and Quasar, and I think it's only going to become both a bigger issue, but also a way to actually fund bridging transfers. If you can make some money off relaying a bridging transfer, you can make them feeless for the end user, and you can incentivize relayers by doing that. For current parties, like different validators that run them, we actually think Voyager is going to be quite popular because instead of relaying between just two chains, you can relay between many chains at the same time. And it's really fitted for us to add support for new ecosystems on top. So some ecosystems we're talking about, talks with Avalanche. We're looking at different roll-up ecosystems. We're kind of observing right now after we launch Ethereum, what's going to be the next one, and basically expand this stack. So for our infrastructure providers, we're looking for ways to make them more money by serving the infrastructure needs.
Okay, but I don't. I mean, maybe I didn't quite understand here, but like going back to applications on Ethereum, are are relayers just are I mean are they interacting with a contract there that is built
Yeah.
by Union or how are they interacting with the chain? Yeah.
Yeah, so Ethereum will have a contract that verifies Litecoin state and it accepts ZK proofs. And that's the first entry point for
Okay.
the relayer. So the relayer needs to obtain that ZK proof from somewhere. Can be that they're running the hardware themselves, can be that they integrate with the proving market, can be that this is a relayer that has specific hardware, FPGAs, and so generates these proofs even faster than the rest. Maybe they have a massive GPU, and so they're basically the ones that submit these proofs first every single time. And with this proof, they can basically clear out the entire packet queue itself. So once you submit Litecoin proofs, all those packets can be sent as well. And for each of these packets, you earn a fee. Some are BPS fees, some are message-based fees. And so for relaying, it's a race to the finish for generating the secret proof, because then you open up the queue for yourself to submit all of these packets. Then contracts and protocols themselves, they integrate with these contracts that that the relays interact with. So basically, they fill up this queue such that the packets are going to be sent on the other side. Relayers can then decide, are they just going to forward every single packet? Forwarding every single packet from Ethereum to Cosmos makes sense, because when Cosmos gas fees are low, it's quite cheap. So probably the moment the packet is available, you just want to send it out. For Cosmos to Ethereum, because Ethereum is slightly more expensive, you probably want some logic to say, I need to at least make 30% on this. That's where the
Yeah.
market dynamic
Or
comes
is
in.
this transaction even valid? Like I mean, yeah.
But yeah, if I see that you're waiting on a 30% profit, I'm just going to set mine on 29% and get the profit every single time. So that's the market dynamic. But where N protocol is integrating with it, it's an on-chain world. It's smart contracts that they're integrating with.
Okay, yeah, that's clear. You said something earlier I want to come back to, and that is that with Union, you don't require the Union will not require governance proposals to set up relays between chains. Can you maybe just explain like why that is? Like why would Union not have to run have to have governance proposals? Because I mean, Union will have to set up relays with all the Cosmos chains, or at least all the IBC chains, correct?
Yeah, so in essence, like for the security of the system, you don't need to do a governance proposal to open these channels. Like that should be permissionless, should be just accomplished. You can think of a model where perhaps they need to put down a certain stake or pay a fee for the bytes that it costs to put this data on chain. But the Union L1 is basically block space purely allocated for this, right? It's not like Osmosis, which wants to allocate as much block
Right.
space to
Okay.
trading. Union is specialized to this. What's really cool is kind of we're not going to have that in our V1, but is once you start thinking about this world where all bridging is Litecoin based and IBC based, is can you do some type of aggregated ZK proof? Right. Right now you got this liquidity fragmentation because you have like the diamond transfer problem. If you start at one chain, you do the same asset to two different chains, you end up in the final one, they're going to be a different asset. Can you generate a ZK proof to show that these two intermediate chains have the same Litecoin state and handle the assets correctly? Because if that's the case, then there's really no need on this final chain to have them as two separate assets. Instead, you're allowed to mint into a single asset. And that's kind of this like future of permissionless interoperability we want to head into, is where like the routing starts to matter less. They create space for parts like Skip protocol to do routing efficiently. Plus, that means as an end user, you really stop caring about like how you transfer in and out of things, and instead
Yeah.
it's just a network you send it out into.
So this just, I mean, this just solves the fungibility problem. So essentially, you're saying that um, if you can prove that the origin of the token comes from the same origin, right? That like, but that the intermediary chains have the same like client verification, then the destination token is the same. I mean, why wouldn't that be not be the case currently for Cosmos tokens? I mean, like if you're moving Atom across like
Yeah.
Osmosis and Juno to I don't know like Agoric, right? Why would not be the case? Is that a technical implementation issue or is
Technical.
there? Yeah, okay.
Exactly, because right now it adds increased complexity in how much block space you allocate for verification. Because now, for not just the intermediate tops, but for the origins, you're also start doing verification. So you basically create direct IBC channels to everything. But because with like ZK proofs, you can do a bigger proof, longer computation time, but same verification cost. You basically can do what you ideally want to do, an IBC channel to every single chain from every single chain for the same cost as just having one single IBC channel open. It's like I think in the experimental specs, like if you look back in the history on GitHub of a
Um, that's cool. No, that's really interesting. Um, does packet forward middleware somehow play a role in this as well? And I mean, do if you solve the fungibility problem this way, then you don't really need packet forward middleware anymore, do you?
exactly, it's technically competing products. Packet forward middleware puts an increased trust assumption on the chain that you're used for hopping at that time, right? And which, like, to be honest, like we don't really see a lot of chains have 2/3 of their validator set go malicious, right? So I still consider it quite a small risk overall, but from like a technical mathematical perspective, it's an incomplete solution. Really what you want, and if you're interested in this, you should read on Spree modules, which is an experimental tech that they theorized in the Polkadot ecosystem. You kind of want a Spree module, which is part of the block transition function that kind of lives outside of consensus. So could live on the Atom Hub, for example, or that you generate a ZK proof for that's like really tied down in how to process this so that you don't need to trust the intermediate chain to handle packet forward middleware correctly. Because I could, of course, like if I write my own chain and have that be the middle point between two other chains, I could fork my chain code and just make packet forward middleware misbehave. And the two connecting chains right now wouldn't be aware of that, and you end up with some issues here. And which is why like you can't introduce fungibility on this. And so if you remove those issues, you open up fungibility. So in the end, like this whole fungibility issue in IBC is an original design, right? They had to launch it, they had to make it secure, and by doing this like denom system, you make it secure but less usable. And by adding these new security primitives, we can get it to a level where then we can actually introduce fungibility.
Cool. What do you think is the timeline to having perfect fungibility between tokens that have passed through different chains?
Yeah, so like after our initial launch, that's going to be the primary focus for us. That combined with bridging new networks. Bridging new networks is kind of application of tech we've already built. While this hacking on this fungibility issue is kind of the next holy grail to add on top of this. Um, I think myself, with now Succinct ZK Tenement being present, Comet BLS being there, with we use NARC ourselves, but in general, like the ZK SDKs and ZK Tech itself has progressed a lot. I'm really hoping to see that in 2024. I'm kind of like hoping, to be honest, that we didn't start the bull market yet with the Celestia and DYDX launching, and that actually, as all of us builders have another full year to implement this, so that when we get the next influx of users, all of this can actually be ready.
That would be terrific. So I do want to talk about Celestia and DYDX and the next Cosmos bull cycle. I mean, specifically, I think I want to talk about Celestia because I'd like to understand how Union what role Union plays there. But before we go there, well, actually, let's dive into that a little bit, and we can talk about shared security a little bit later. So, yeah, in the context of Celestia, which layer of the stack does Union intervene? I mean, do applications have to integrate directly with Union, or does interoperability happen at the lower layer of the stack?
So let's start out by seeing like modular development as a SaaS solution where you need to pick like different Legos to put together. Data availability is there because you can verify secret proof, right? You can show that you did something correctly in a rollup without ever showing people the original transactions, which means that if the centralized sequencer were to disappear, you wouldn't be able to start up a new sequencer by someone else. So Celestia solves this issue by basically being able to provide you proof to say the original data that you need to kickstart a new sequencer is available with us. And that's how you prevent like data withholding attacks and such. So there's one building block. And another building block is the actual verification itself. So Celestia plays in and say like, if you're able to verify yourself, someone else will be able to boot up a new sequencer to continue verification in case you disappear. They don't make assumptions on are you able to verify yourself? Are you able to do you use are you seeking rollup or optimistic rollup or whatever? They're saying if you need to promise that you're able to get some data, we provide it. As a rollup or app chain, you're basically providing this like verification guarantee, right? Like you define your rules on if you have the data, how can other parties verify that you are transitioning blocks correctly, which is Lifeline Tech, Cosmos Tech, ZK Rollup Tech, etc. Then where interoperability really comes in is saying, okay, can we take these models that different teams are providing on how to verify their state, and can we tie them together as a baseline to allow them to communicate with each other? Now, in an ideal world, everyone will be on exactly the same consensus because that would make our lives easier. In reality, they're not. They're all on very different types of consensus with different guarantees. So as an interoperability protocol, that's what you're most focused on with integrating it. Another portion is what we kind of discussed, this pre-module part, right? Like if we can verify their consensus, can we also verify part of how they handle transactions? Because if we know that they handle bridging transactions correctly and they don't misappropriate packet forward middleware, etc., then they can become a permissionless part of this cluster. So Union really wants to be like another building block that you can pick when you're building a new rollup or when you're a protocol on a rollup where you go, I'm going to pick IDA or Celestia for my DEA. I'm going to pick IBC with Union for my interoperability. Union supports hot stuff consensus. Nice. That's what I'm building on. And so you kind of connect all of this together and then you launch your chain. And for me, what I want to see then is obviously that you just start producing blocks and can immediately send funds to Ethereum, to Osmosis, to Injective, etc. Right. And basically immediately be integrated in this full stack.
That's the dream, right? So, yeah, I mean, that would be ideal, right? You just like launch a chain and you can just send tokens between any ecosystem. So you mentioned Eigenlayer a little bit, and yeah, I was talking to the Electron team earlier this week, and they sort of opened my eyes to this really interesting use case, which this sort of enables is being able to leverage Ethereum stake for Cosmos chain. So essentially being able to use interchain security across Ethereum and Cosmos, and that just like blew my mind because I didn't know that this was possible, right? And I didn't know that ZK enabled this. So I'd like you to explain how that works and what are the potential ramifications for Cosmos. You know, I think if we take a step back a little bit, like Cosmos alignment is like a dividing issue in this space. Like some people think that Cosmos should align with Ethereum. There's a few people who think that Cosmos should align with Bitcoin. I've heard some people say that, right? Um, and others think that like Cosmos should just remain its own sort of sovereign ecosystem that doesn't align with anything and that derives value and sort of like grows its value by building great applications and particularly being like a governance hub for the ecosystem or the broader blockchain ecosystem. So yeah, I'm curious to think just to hear like what you think this unlocks and what it enables for the Cosmos ecosystem, like if we were able to use e-security.
Yeah, so I think it gives Atom kind of a kick in the butt to start building, developing, and upgrading, right? Because this provides like Ethereum alignment and basically what Atom could provide Cosmos chains, which I think is a really strong proposition for new chains building. Ethereum has a lot of liquidity, a lot of users. If on the tech perspective it can outcompete Atom itself, then you get the best of all worlds. You get your Cosmos SDK chain, you get to pick EigenLayer as your DA, but you get to pick shared security with Ethereum and have close connection to that. For me, like I'm not necessarily like a single chain hub maxi. Like I don't necessarily think we're gonna get one hub altogether. I don't think it's gonna completely outcompete Atom as well. I do think it puts to question if like Atom itself like is overvalued if this becomes an option, right? What they did with Ethereum is amazing. They managed to create a network where you want to stake the token. It's deflationary or very close to it. You're willing to pay the fees because there's enough value on the chain itself. And now with EigenLayer, you can even buy more functionality there and hopefully actually benefit from a disproportionate set of security than you're paying for. With Atom at the moment, we kind of figured out that security portion, but we didn't figure out the rest of the flywheel there, which I think is the biggest kind of handicap it has right now, where you question like, why do you hold Atom? Is the only income you're going to get from chains that run security? If there's other options out there, that's going to be an issue for you. On the other hand, I think Atom is much better positioned to capitalize on being the forerunner here, basically doing all this tech first and doing it better, right? Like it's already built for that, it's designed for that. What would this unlock? Well, we saw like stuff like Atomic IBC, right, which is a great candidate for capturing cross-domain MEV, for intent settlement, etc. Which I think building that on top of EigenLayer is going to take many more years before we're going to see anything like that arrive. When I was exploring EigenLayer myself, like the specialized operators, the AVSs, etc., they were all very much early stage. You could rent security, you can rent security from EigenLayer, but not a disproportionate set yet. What you can limit is still relatively, what you can build is still relatively limited. So I don't think we're going to see that outcompete yet. For Union, like what's interesting is to see if we can leverage both at the same time. And I think that might be really interesting for a lot of chains connecting, is basically not take the gamble on either ecosystem, but be able to move with each ecosystem as they technically progress. I do think that with the new kind of designs for Atom and Atomic IBC is going to be like a really interesting counterparty to EigenLayer. And for me, at least, more competition is better, right? Like Sommelier kind of stopped a bit of their development or slowed down until Quasar arrived, and then all of a sudden they went aping again, and now they got massive TVL growth in the bear market. So putting EigenLayer as a potential competitor to Atom can be a really, really good way to push forward the technical limitations.
Yeah, and I just realized I didn't ask you about this, but in your Cosmoverse talk, you were talking about how Union will also enable Bitcoin transfers into IBC. How does that work?
Yeah, I'm actually really bummed about BitVM because this is some research Hussein and I did like 5 months ago where we had like a similar design for verifying CK proofs on Bitcoin, etc. And basically
What,
trying,
BitVM?
I don't know if you saw that on Twitter. You should check this out. It's
No.
kind of like
Yeah.
smart
Okay.
contracts on Bitcoin. It's still like computationally way too expensive to run, but basically allows for general purpose programming on Bitcoin. And we had a simplified version specific for like IBC transfers, which was going to be initially like the next ecosystem we were going to do after Ethereum. Now, Nomic has been doing a great job, Babylon as well. So we might reconsider this and kind of see if rollups are actually more of an interesting target and just publish BTC IBC as a research paper before we pursue it. But at least the way I see it as kind of an intro protocol and as a like interoperability cluster, you are valued in the assets that you give your protocols access to, right? You do a partnership with a DEX, with certain protocols. What new assets can you bring in that the users will want to use? And Bitcoin is immensely interesting because there's obviously so much stagnant liquidity there, right? Assets that are not earning any revenue that could be doing something at this time. Obviously, there's like Rep BTC and Trusted BTC and IBTC. Well, Rep BTC is managed by a company, right? So if something goes wrong there, then we have a massive issue, which given Murphy's Law, like anything you imagine like will go wrong, it'll bite you in the ass at some point. IBTC is collateralized by other assets, so it's like quite capital inefficient. Because you're not technically like bridging over Bitcoin, you're locking it, you're locking an additional amount equal to the value of BTC, and then you're minting a derivative that represents that value. So it's not capital efficient, so you're not really going to touch it too much. And Trusted BTC kind of has those same issues where you need to like load up vaults to actually be able to maintain these Bitcoin wallets themselves. So for me at least, IBC is a really cool solution to solving this and actually get capital efficiency. Then the question, of course, remains: can we convince the Bitcoin crowd to actually do something with their coins, or are they just gonna refuse to participate in DeFi and sit on it forever? Really depends. We've spoken with loads. Half of them is willing, and the other half is gonna basically sit on it until they die and say one Bitcoin is always one Bitcoin. I'll never spend it.
Yeah, I'm looking at this paper. I mean, I haven't read it, but it's like what's impressive here is that it's only 8 pages, so basically the same length as the Bitcoin white paper. So I'll have to read this later. Um, but in the case of Union, like how will those transfers work specifically? Are the validators holding some sort of a multi-sig, or like what's the
So basically, what we're doing is kind of like implementing the mechanism that BitVM uses to verify proofs on the Bitcoin side. You probably wouldn't get many channel support, probably just be a single
okay,
channel that you can do. So you're kind of getting close to IBC semantics, but not in full, but like
right?
acceptable enough. And then on the other side, going from Bitcoin to other networks, what you'll be doing is basically verifying proof of work in ZK proof, and then
Yeah,
tying the amount of work to the security level. Because Bitcoin, of course, never finalizes, right?
yeah,
There can always be a competing chain, but luckily it's so expensive to mine Bitcoin that if you wait for a sufficient amount of confirmations, you can be certain that there's not going to be a competing chain out there. And so that would be the fundamental mechanism powering doing these transfers. And with tech like BitVM, you basically can do arbitrary logic, lockup of tokens, consensus upgrades, validator rotations, etc. So that's a super interesting space. BitVM has some limitations, like if you read the paper. So it's like really early on. For us, we didn't need to do general purpose programming, right? For us, we were looking for something way simpler to build. Um, so that's like super interesting too. I think that's going to take a while, by the way. Like building on Bitcoin is an absolute pain in the ass.
yeah.
Very different stack again. All the stuff we explored, we have a design for doing Cardano. That was more of a meme thing we built in the weekend. One of our lead developers is a big fan of Haskell. So we were like, can we do IBC to the Ghost chain? Still a lot of value locked there, to be honest. And from a tech perspective, very interesting. So could add a lot of value to existing Cosmos chains, right? They're looking to broaden their products and their user base.
Yeah, this is cool. Thanks for sharing this. I'm gonna read this paper later. Um, so what's on the roadmap? Like what because you guys just sort of came out of stealth um, at Cosmoverse. Like I remember seeing your deck circulating sometime in July, but then like we were organizing Nebular Summit and it totally like went to the
Yeah.
to the side, and then you guys like popped out of Cosmoverse and announced this demo and sort of came out of stealth. So what's next for you guys? What's on the roadmap, and where can people like get involved and start thinking about building on Union?
Yeah, so the next thing we have for the community to share is transfers. So I have it on my PC here right now. We were doing some final RPC hardening today. So hopefully we're actually going to be publishing that tomorrow. That'll include like integrating MetaMask with Union testnet, acquiring test unit tokens, and basically like the first play around with everything. It's going to be like a bit scary too because our initial demo ran like ping pong, but that doesn't really like stress test the RPCs, right? And it doesn't expose too much about the endpoints we're running. So if someone wants to try DDoSing our testnet or my poor validator nodes, then they can do that from the next demo on. And then really focus on public testnet. Right now, we've basically decided on the first 10 validators that we're onboarding. With public testnet, we're immediately rolling out Comet BLS v2 with the like even more efficient proving itself. So we're hoping to actually bootstrap that network either end of this week or next week. What's kind of stopping us from doing it this week is our CTO is getting married this Friday. So actually, the entire team is here in the Netherlands on a retreat and ready to celebrate his wedding.
Cool.
So that might like delay our timeline by a week for testnet. And from that moment on, teams can start building. So we've been working a lot with Kaiser, ideating on their Ethereum product sets on the ICQ that they built, and basically getting them ready to immediately leverage this product. We've been talking with loads of teams from the ecosystem. Teams I'm super hyped for, Parachain, Injective. I'm actually really hoping to build something cool when we launch with Agoric and IST. I think that's going to be a really interesting opportunity, because the way I see it is, there's going to be a chance for us to kind of re-show the Cosmos ecosystem to Ethereum and get in an influx of users in TVL. So it has to be like a combination of different chains and different products all working together over IBC, with Skip, with TFM, with 42, with Squids, to show like a unified experience across these chains instead of this fragmented, sharded experience. I think if we can do that well, then there can be a massive influx for TVL and revenue for almost all chains.
Super exciting, Karel. Thanks so much for coming on the podcast today and sharing all this knowledge. And yeah, I'm really looking forward to seeing all this like really innovative stuff. I mean, I think a lot of this infrastructure that you're building unlocks so many use cases, but also just improves user experience all around. I mean, like just the fungibility aspect, like that just blows my mind. But the ability to be able to use Ethereum stake to secure Cosmos, that's like a massive unlock for the space. And token transfers, like or like message passing. That in itself, being able to do that in a trust minimized and permissionless way is going to be massive for the ecosystem. So we'll be following very closely as you guys continue to build and ship.
Perfect. Thank you so much.
Thank you.